Welcome to the Curiosity Crisis. We challenge ourselves to explore the world of business, tech, investing, and science. Get curious and be part of the journey as we discuss, challenge, and learn.
Mitchell Scott is the principal data scientist at Consilio, where he works in the rapid prototyping team, developing specialized large language models for legal problem solving, a unique blend of solicitor and published data scientist. Mitch helps create cutting-edge AI tools. His algorithm for identifying gendered language in legal drafting was shortlisted for the 2022 Financial Times Innovative Lawyers Awards. When not breaking LLMs, he's skiing, running, or coding. Mitch, welcome to the show.
Thanks so much for having me. Really excited to be here.
Very excited to have you.
Yeah, super excited for this episode. I'm going to get my mind expanded, I think.
Hopefully a good one. We like to start things off with a consistent question. What's keeping you curious at the moment?
That's a really good question. So I think what's keeping me curious at the moment, I've been I like jumping into lots of different things and like understanding lots of random different topics that are well outside of what I probably can or should know about. One of the things that came up recently, so my partner has just kind of moved companies. She's working at a solar thermal company at the moment, so I've been learning a lot about that.
Very cool.
As energy guys, you probably have a lot of opinions on solar thermal. And one of the cool things they're doing is like thermal batteries. So the idea of like storing energy as a big reservoir of molten salt and then kind of dispatching it as required. That's just been blowing my mind. Like kind of the way they do that, the issues with like trying to prevent like molten salt from corroding whatever it's being stored in.
Yeah, corrosion's a big problem for salt batteries. Yeah, it's very interesting though.
Is it? What are the changes of energy flow? Sorry, so is it? We're all nerds at energy, but like, is it the solar just directly heats up the molten salt? Like, is it the reflective towers going into the molten salt holding or cavern, heating them up, and then later on it gets turned into electricity, or is there a few transfers?
Yeah, as I understand, there's a couple of transfers. I was no expert, but kind of special interest at the moment. So basically, the reflected solar kind of big array of mirrors beams it to a central tower that has its own like sodium, like molten sodium loop, and that sort of goes round and keeping that like stable and never letting it kind of solidify is one of the huge things. Because if that molten salt becomes solid salt, then you kind of have to break the whole thing open and kind of restart it. Then there's like a heat transfer, and there's like the heat exchanger will exchange all that heat into another molten salt loop that kind of goes into the heat reservoir, basically. And then you can dispatch that as either heat or heat that turns a turbine and makes electricity. So you can use it for like industrial heat, things like sustainable aviation fuel or sustainable like fuel, basically, creating that. So yeah, it's just absolutely fascinating. I never even considered you could store heat in a real kind of industrially effective way.
That's so cool.
That's right up Chris's alley.
Yeah, love that.
I can see the mechanical engineer.
No, thanks for sharing. We'll get straight into it, and won't talk about energy all day because you're an expert in another field that we'd love to get your thoughts on. So what is your role as a principal data scientist? And I guess maybe what do you do at Consilio?
Totally. So as the principal data scientist, I kind of run a team of data scientists inside our research and development division over at Consilio. To kind of understand what we do, probably helps to touch on what the company does. So Consilio is like a legal services company that spans the globe. We've got offices everywhere from like Frankfurt to Washington. And the company recently came to Australia, I think early last year. And that kind of coincided also with this huge like rise of Gen AI being used inside enterprises and to help kind of legal work. So I actually have a legal background as well as a computer science background. So I sort of found myself in this team, and we started kind of making products that could help this kind of litigation discovery side of the legal industry. So yeah, we sort of like focus on creating products that help the process of like reviewing documents for litigation discovery. So yeah, basically the litigation discovery process is when you have someone suing someone else, and that person has to go and disclose a bunch of documents that are relevant to whatever they're being sued about. So you basically have to go and review kind of tens, hundreds, thousands, millions of documents in order to find the stuff that may or may not be the smoking gun in that lawsuit. And traditionally you do that with a bunch of humans. You kind of throw them in a dark room, you lock it and say, you can see your families when you've reviewed these documents. These days, there's a lot more machine learning involved in that process. And we're sort of finding ways to apply language models to that.
That's really interesting. So, like, I guess my understanding definitely of legal practice is it's, head buried in the books and documents and stuff like that. It's really cool. It feels like a huge modernization of the space.
Oh, totally. Like, I remember seeing there was a lecture I think I saw back at university, which was, they were comparing kind of how surgery theatres had changed over the last kind of 100 years versus courtrooms. Yep. And they had a photo of like a surgery theatre in like the beginning of the turn of the century, and then in kind of the year 2000 versus the exact same courtroom, which had not changed like whatsoever in like 100 years.
Yeah.
So I have a hope, and I do actually genuinely think that the legal industry will be galvanized and kind of maybe forced to change in a way it hasn't previously by this technology.
Yeah. Just so much change going on out there, and like regulations and legal frameworks in so many different areas, obviously AI being one of them, hot topic, but there seems like there needs to be a huge modernization of a lot, which is really interesting to hear.
Totally.
that you do work in that space. Moving on, what types of AI implementations are you seeing gain the most traction in enterprise environments today? That might just be a more general question and observation, but just keen to pick your brain seeing as you work in the space.
Totally. So, I mean, when I look at kind of businesses who are using Gen AI, and more specifically kind of language models rather than... I'm not so much the expert on image generation sort of technology, but when it comes to language models, I see kind of two places where businesses are effective at using them. They kind of break into like two broad categories. I'd say one thing is helping humans do complex tasks. The other one is automating kind of uncomplex tasks and doing them at scale. Kind of imagine like a bulk autonomous sort of completion mechanism. So that first one, if you think about the rise of like vibe coding, people who, coding is objectively it's a difficult thing. There's a lot you need to know. You're constantly kind of learning stuff and having to like figure out how to like solve the next problem. So having a language model, especially a very powerful one by your side, is something that kind of helps enormously increase productivity. The same is sort of happening in the legal industry as well. Lawyering is traditionally, as you said, kind of heavy, like head in the books sort of research oriented, or you're kind of poring over the meticulous detail of a contract, and having sort of like a co-pilot, a co-counsel, if you will, to be next to you helping you do that is increasingly becoming more of a viable thing that helps productivity. Then on the other side, I think you can think about it in terms of, these sort of low complexity tasks that take up a lot of time. They're really painful, but they have just enough variance that you can't automate them, but not so much variance that they're actually difficult. It's kind of like mind-numbing work. Like back in the day, I used to kind of do that very first base level doc review as my very first job. So I'd come in and I'd, stare at my screen and I'd like say like, this document's relevant to this litigation. Yes. This document's not relevant to this litigation. No. And, it doesn't take a lot of brain power. It doesn't take a lot of like time to do each document, but there's enough variance that you kind of do need to sit down and think, okay, this is a hard one every now and then. So we found that sort of like first level doc review was sort of a really good use case for that. Effectively applying it as like a bulk operation.
It's kind of like that difference between having really structured data and being able to run some form of machine learning on it versus having unstructured inputs, but it's like not that much of a differentiator. You need that first, is this related? Is this not related? And being able to then tackle it by tokenizing is actually really useful. I can totally see that. Yeah. So I guess, following on from that, something a bit more complicated is, I guess, especially, on the software engineering side and the more technical side of Gen AI, MCP's really taken kind of the world by storm a bit. I think it was a bit of a slow burn initially, but now it's really kicked in. I guess I was hoping you could explain, what is MCP and kind of how does it change AI workflows, and how does that compare to the traditional integration of AI systems? Totally.
I think, MCP is something that's definitely had a lot of like hype around it, and I think it came in with a big bang, and then people have sort of been figuring out like what it is. So to give a definition, MCP is Model Context Protocol. Is what it stands for, and effectively you can think about it as a universal standard to give context to a model, like a large language model. Context in this case is additional information that a model needs to do its job. So, for example, if you are trying to answer a question about a document, having that document is context. Or if you ask a model, for example, to tell you the weather, you might want it to have access to a tool where it can say, specify the location and then retrieve that information from elsewhere. So in many ways, MCP is sort of like the gateway between the model and like the outside world. The funny thing is, we've been doing, ever since language models have become a thing, we've been doing this sort of thing. We've been inserting relevant context into kind of systems that use language models. You might kind of have a very primitive one where you have like a template and you basically just fill in the template with the information you want the model to have. The MCP is sort of like a standardized way to do that. So the benefit is you can sort of just plug and play with all the different kind of MCP servers that are out there. So maybe a good analogy is like, if you think of Python, one of the great things about Python as a coding language is it has access to a squillion libraries that people have written for it. You know, if you want something done, there's probably a Python library that will do it for you. So MCP is a similar idea.
Yeah, like I guess the future of it could be something similar to like a package manager where you take the things that you require and you plug it in.
Totally.
Yeah. No, that's a really good explanation. I really appreciate that.
Yeah, it seems like one step before using the large language model, I guess organizing what's there and making sure that it's effective for it to flow through the LLM after.
Totally.
What has been, in your opinion, what that you've seen working in the space has been the biggest value add from an AI solution that you've seen so far? So what has sort of blown your mind or changed the game in your perspective?
Ooh. I mean, I think... So I'm a big open source nerd when it comes to this stuff. I think I'm pretty biased in that respect. But I think the things that has really kind of blown my mind in the recent past is like what you can do with small models. Okay. So like I think GPT-4 made a huge splash when it came in and it was, you know, very impressive for what it could do. But that thing is enormous, you know, like we're talking... I mean, I don't think the actual number of parameters has ever been released, but we're talking, you know, fleets of GPUs that need to run this thing. It's chewing up carbon like you wouldn't believe just to, you know, answer very simple questions. And over time, we've seen this really interesting, I guess, yeah, like an efficiency gain as people have been able to make smaller models that can do equivalent tasks. Like I think the models that are like 8 billion parameters today would be competitive with GPT-4, which might be over 1 trillion parameters back when it was released in like 2023. So there's something really, really special about being able to run this sort of stuff like on your laptop, on edge devices, or even just at scale, but like massively parallel, like on fleets of GPUs. So I think the main thing that in terms of like efficiency gains I've seen is like being able to harness these small models, like maybe fine tune them in order to get them to do one task really well, and then just kind of massively parallelize that. Obviously very relevant to what I do, but also very relevant to kind of any task where you need to analyze a lot of data in a very small amount of time with a reasonable amount of intelligence.
Right, so it's just a way more cost effective and I guess efficient in terms of energy use and compute power way of doing the same thing. Does it need to be really specialized in terms of the application? So each small model for one application, or how does that work?
Yeah, that's the interesting thing about when it comes to fine tuning language models. So the way to think about it is when you have like a big language model, they can do a lot of different tasks relatively well. Like if you ask, you know, ChatGPT to write you a poem and then to write a piece of software, it's going to do both of them, you know, relatively well as you'd expect. But having those capabilities at the same time, you're sort of paying a tax, like an overhead of it being able to do all these different things and you're only picking one. So the difference is when you fine tune a small model, you know, it has kind of maybe more mediocre capabilities in each of those different kind of areas. But when you fine tune it and you focus it on a single task, it can actually exceed the capability of a larger model.
Yep.
But the difference is it can only do that one task. Suddenly it becomes really good at giving you exactly what you want in this one area, but you know, terrible at generalization. So you've got to pick it for tasks that are like well-defined. Like you're not going to have too much random variance that's thrown at you. So you might not want to do much fine-tuning, or you might not want to do heavy fine-tuning on a task that interacts directly with humans, because humans throw all sorts of random stuff into systems. Like, we're messy, you know? But for systems where you're sort of doing a very well-defined task, maybe you're like a spell checker or some sort of like, you know, very well-defined single-use application, you can get these things to run super fast, super effectively. And you kind of get that consistency, which is really the fallback of most large language, so the downside of most large language models.
Right. Even if it's just coding, which is still seems like a larger branch of, you know, information. The first time I ran Quen Coder on my laptop, I was just thinking I could be on a flight with no internet and I could be doing so much stuff with this. This is so cool.
It's so awesome.
Yeah, it's really eye-opening, actually. It was like, wow, you can do some pretty cool stuff with this.
Yeah.
This episode is brought to you by Field. 1 in 4 business owners struggle with missed appointments, payment issues, and managing their team. Field fixes this with automation, marketing tools, and all-in-one payment solutions, helping businesses run smoother and even generate passive income. Know a business that could be doing more? Visit field.co, spelled FIELDD.co, to get started for free or chat with their team today.
Sorry, I'm going to jump on because my next question is very, very related to that, and it's talking about it's basically what is the most common mistake companies make when deploying AI solutions, and I think you might have alluded to one of them being just a tax paid on AI capability, or a really large, broad, does everything AI model. But yeah, what would you say are the biggest mistakes or most common ones that are made?
Yeah, so I come from a bit of like I used to work in startups before I got into this more like corporate realm. And I think the same mistake that people make when they're starting startups is this, the same sort of mistake when people are kind of coming up with new ideas and projects to do with AI. And that's the universal problem of trying to fix the wrong problem, or trying to like make a square peg into a round hole. Some things just aren't meant to be solved with language models. And for example, there are a lot of things inside the legal industry where you kind of need it to be right. It needs to be right 99.999% of the time. And if you're using a language model, you just can't get those sorts of guarantees for certain tasks. So, I would never kind of ask a language model to redraft a contract and send it off to someone else without reading it. Like, that's just not going to be a workflow that's ever going to save you time, considering how bad it is when it goes wrong. So, yeah, maybe to circle back on the actual question, like I think the main problem is trying to get a task that is too complex and solve that with a language model.
Yeah.
I would also like follow up with that. Is something that I've looked at a lot is that, you have this non-deterministic output. And so, especially with calculations, I think is a really good example of like something that they're not very well equipped for. It's like, why would you feed something a bunch of calculations when you're asking for, the token breakup to be something that doesn't quite work, and then the maths doesn't work out? It's, you don't want non-deterministic for maths, for example.
Totally. And I think people, like, what LLMs are good at and bad at is really unintuitive for most people. You think, it's AI. We've seen Terminator, we've seen Skynet. Skynet's pretty good at doing calculations. Like, why would ChatGPT not be good at like multiplying large numbers? And it's not till you really play with them that you understand kind of like where the downsides are and where the upsides are. Because ChatGPT can multiply any number 100% correctly as long as it's able to write code. So, like, why is writing code so much easier than performing calculations? It's very unintuitive.
100%. Couldn't agree more.
And it is actually just such a journey of discovery because, you're just using it at work and day-to-day life. Like, I've tried lots of different things, and honestly, I think things have taken me, even though I've learned a little bit about prompt engineering and stuff like that, things have taken me longer and are less efficient trying to use AI for them. But then some things is cut down like 2 days work into 2 hours sort of thing, which is
totally
amazing. Again, last with the broad ones, but if you put a finger to the sky, looking at the progression of AI and now how you use it and how you work within your team in the legal industry, what do you think the progression of the future of using AI in industries, like really regulated industries or really specific industries such as legal and more generally, like what are the changes you see coming in the progression of the next 2 or 3 years?
It's a very hard industry to make predictions about.
Yeah.
Well, I mean, AI specifically, just because, would I know we would be here a year ago? Absolutely not. But I think things are sort of stabilizing at this point in terms of what's happening, what's being released on the AI side. So there's definitely, like a year ago, there was this like Cambrian explosion. I love that term. Like, the Cambrian explosion of like life as it sort of diversified, and suddenly we went from having a couple of microorganisms to like a squillion different types. We finally see like this diversity in the fossil record. Well, in AI, the fossil record's in Hugging Face.
Yeah, that's so true. And soon to be probably agents. And like
exactly.
Yeah.
Like we can already see like a rich graveyard of things that have kind of come out, been cutting edge, and they've been superseded already. And from just a couple of companies who could make a handful of mediocre models to many, many organizations, some of them not even companies, who are putting out incredible stuff daily. So I think that Cambrian explosion has sort of happened over the last year. I think we're going to continue to see this sort of like more models for more purposes, more of them like fine-tuned for individual use cases. So less like generalized stuff and more kind of use case specific. I think there's also going to be diversity in model sizes and what they're used for kind of the reasons I spoke about earlier. The other thing I think is people have been kind of toying with multimodality when it comes to kind of open source models for a little bit. Like we've had the Microsoft's Phi models working with multimodality, and it's kind of been interesting, but I don't think it's quite gotten to a level where you could put a lot of those models into the same arena as, say, like GPT-4o. So I think that's going to be one where we're going to see some like really good multimodal models coming out of the open source realm and actually be competitive with what the proprietary labs have. And that's going to change the game in terms of, on-device usage. If you have something on your phone that can talk to you or that can see through your camera and tell you things about the world, that's a very, very different proposition to just text in, text out.
And maybe some really interesting companies or startups would come out of that as well, with just the ability to, well, it depends on the license that's attached to the weights and the model. But
Totally.
Yeah, I mean, I think, the future, especially in open source, will be really interesting.
Yeah.
Following along with size of these models and kind of like looking at the future, how do you see the neural scaling laws and kind of this pivot from kind of pre-training into post-training a lot? And we've kind of talked about that a little bit with the sizes and kind of not being generalized into really like focusing on a specific task as to what it's going to be good at. But I guess could you explain what those laws are and then kind of how it may or may not affect the future of the space?
Totally. So there's sort of a series of scaling laws their existence was proposed by I believe it was a Google paper that was...
Yeah, it's DeepMind.
DeepMind, yeah.
I think. Yeah.
And I think they were called at the time the chinchilla scaling laws, because they put out a series of models called Chinchilla, and that kicked off a whole lot of models named after animals like llama and so forth. And so basically these scaling laws say that for a certain parameter size, so a certain size of neural network, so you can think of a parameter like a neuron equivalent in a brain. So more parameters is more powerful, but also takes more computation to run. So for a given parameter size, there is an optimal amount of training data that you can train the model with. And if you kind of go past that, then you kind of get a point of decreasing returns. So the original chinchilla scaling laws were saying that you're better off increasing the size of your neural network rather than adding more training data after a certain point. And I think exactly where those laws have ended up has sort of been shifting over time as we made architectures better, as we hoovered up every piece of data on the internet and shoved that into our training sets. But we got to a point, I think it's fair to say at this point, we're getting to a point where we're getting decreasing returns from our current way of training language models. There's not a lot more new data, and the data that's currently being used is being the architecture that we're limited to, which is the transformers neural network architecture. It's kind of limited in terms of what it can do with the data. I think the way I like to conceptualize it is, as a human, you haven't read the entirety of the internet, but you can probably navigate life pretty well. Like you can probably make an educated guess about, if I drop a ball onto a cake, is the cake going to explode or is it going to set on fire or is nothing going to happen? Like we can reason about the world in common sense ways without needing huge amounts of data. So I think in order to kind of squeeze a bit more performance out of these models, something that was kind of was come up with last year, I believe, was reasoning, or kind of test time compute is the data sciencey way to say it. And effectively that's asking the model to put in like a reasoning trace in, so think through the problem before it answers the question. Mm-hmm. And those reasoning traces, they're very, very interesting because they look a lot like how a human would sort of think through a problem. They're kind of very like anthropomorphic in a way. You can see it be like, oh wait, but that actually doesn't make sense, and just kind of like correct itself and do these like human-like behaviors.
Reading through it's very odd, actually.
Yeah, I find it like kind of a little creepy sometimes. It's really trying to imitate how humans think.
Yeah, it really is.
Yeah. But I think one of the really interesting things to come out in the last like 6 months was this, not exactly a groundbreaking discovery, but just kind of the confirmation that they're not really thinking in any way that is parallel to how we think. And in fact, sometimes that thinking process doesn't actually belie what its end answer is, or it activates different parts of the neural network associated with different concepts to the ones it actually says in its reasoning trace. So it's very interesting that like this process is helping it come up with a better answer. But sometimes we can't kind of confuse that with being like an explanation of why it gave the answer. Like, it's still just, it's an evolution of that autocorrect on steroids. It's just predicting the next token over and over, and this is just a way to do that slightly better. It's not cracking the cognitive code. You know what I mean?
I think that's a really good way of explaining it, actually. And I think specifically knowing that it is not, a parallel way of reasoning the way that we do. Because, it really is like a correlation does not equal causation, especially in this. When you read through the reasoning and then you see the output, and sometimes you're like, what? How?
Yeah.
I think that's a really good way of looking at it. I wanted to ask a little bit about some of kind of the open source models that there are. Mm-hmm. So we had this kind of massive impact on the market with the release of DeepSeek R1. And I think there'll probably be some more impact with Qwen as well. And I just wanted to talk to you about kind of like, the commoditization of AI and kind of where, just having this like intelligence as something that can be sold and bought and used, and how things have really impacted, especially in terms of open source versus closed source, and kind of what your thoughts were on that.
Totally. I touched on this a little bit earlier with that idea of that Cambrian explosion. I'm gonna copyright that term. But so I mean, back in the day, the very first kind of usable language model was from OpenAI in terms of usable for like common tasks. That was ChatGPT. And if you think about that, they really had this monopoly on providing that service. And that service was, I don't want to call AI like actual intelligence, but it's a form of intelligence or a form of like cognitive service. So they had this model, it was incredibly valuable. People would have killed to put their hands on it. And then other people came up with similar things. Anthropic released Claude. We had this kind of entrance from like Gemini, so Google's Gemini and all sorts of things. And so suddenly OpenAI wasn't the only kid in the block. There were actual competitors, and they started getting better and better. A couple of closed source labs had access to these models, and they were still very valuable because no one else did, but suddenly there was some competition. And then basically Llama came along, it was open sourced, and then the open source community did something pretty incredible, which was invent a bunch of things to allow it to run on consumer hardware. And that, I think, kind of pushed the field forward maybe like years in terms of like all these different people working on this. So just to nerd out quickly on a little micro point for a second.
Yeah. No, this is great.
Yeah, I find this so fascinating. It's kind of like the intersection of like economics and like psychology. But basically, we got this Llama models released to a couple of universities. It was leaked almost immediately, as you'd expect. And then some very, very smart people found out how to run it on a laptop. So they invented llama.cpp, which was effectively a way to efficiently run it on consumer hardware. And then I think also quantization was either invented or popularized by this community. And the joke was, like, within about 4 weeks, Llama could run on a toaster. Like, it was incredible. It went from this, like, supercomputing realm to, like, yeah, mate, I've got a laptop, I can run that.
It's like how Doom, like, people run on, like, a microwave.
Exactly.
It's like, how far can we get this abstracted away from its original purpose and run on whatever?
I reckon in the future we're going to have, like, can this run Llama? Will be, like, the new, like, test.
Yeah. It would not surprise me at all.
So, yeah, that was sort of the start of this, like, OpenAI, like, renaissance effect. Sorry, this AI, open source AI renaissance. And very quickly, like, these models, like, Llama was not good. It wasn't comparable to ChatGPT. It was kind of not useful for many things. But it improved exponentially fast. To the point now where I think it kind of flew under the radar for a lot of people until DeepSeek came along. And DeepSeek was famously competitive. Like, they released a model completely open to the internet, and anyone could download it and run it given the right hardware. That was competitive with OpenAI's leading model at the time. So basically OpenAI, which was kind of the kingpin, they had like the best technology, the best service, and suddenly you could download this model and run it anywhere for literally the cost of the hardware and the electricity. The cost of the model effectively went all the way down to practically zero. And if you think about that overnight, that's crazy.
Especially with, like the value of that business, OpenAI, versus the cost of running, like anyone running something relatively similar results you would be produced for, fraction of
totally.
The value of that business is crazy. Yeah.
We're just taking a quick break. We'd love it if you did us a favor and gave us a 5-star review on your podcast streaming player. We'd really appreciate it.
And sorry, when you're saying download it and run the model, you mean like actually build upon it and sort of grow it, or just like use it as like a...
Just use it as is.
Okay,
if you have I think it would take 8 NVIDIA H100s, so there's commercial grade GPUs, but you can just go rent a couple sitting in the cloud somewhere and just deploy DeepSeek. And then you have literally for the price of the compute rental time, you could just use it as much as you want, make as many tokens as you want. Suddenly the model itself costs nothing, and you're effectively just paying for the physical real world objects you're using, being power and hardware.
As opposed to paying OpenAI for the service to use their model, because they are doing all of that overheads and stuff behind the scenes. Yeah, okay, cool.
Exactly. And they've invested a lot into creating the model, and therefore their product has a markup, which helps to recover their costs, which is a very traditional and normal R&D sort of cycle. But I think what was really interesting about DeepSeek is that if you suddenly devalue that to a point where your ability to recoup your costs is very, very low, then suddenly investors are going to freak out, because they've given you a lot of money to hire some very expensive people, buy some very fancy hardware, and then go train these models with the idea that you can make a profit. So what happens when suddenly that service is offered at a loss for free everywhere?
And I think something that also contributed to this was, just one example is artificial analysis is a third-party tool that monitors performance of models. And so I think they try and stick clear of having an incentive to, fudge the numbers. But essentially, you had third-party kind of tests and publishment of that, those results, and saying, hey, this performs pretty much the exact same as the leading-edge foundational model. Yeah,
it was a kind of it was a crazy time, and obviously NVIDIA's share price just tanked overnight, and then people went, hang on, what are you going to run these big models on? And then it went back up.
Exactly.
Kind of a funny reaction, because obviously there was a lot of investors who perhaps didn't fully understand where NVIDIA sits in the ecosystem, and thought, China model scary, and kind of just dumped the stock, and then they went, no one else makes GPUs, they've got a stranglehold in the market, and it went back up.
It would have been crazy if OpenAI and a bunch of those, obviously Google is listed, but OpenAI and whatnot were listed as well. How the fluctuations would have been for that. It would have been crazy for public market.
Oh, totally.
That's so true. Yeah, if OpenAI were listed at the time, it would be fascinating to see a 50% drop or something in share price.
I think we actually would have seen that. In fact, I think we saw it a little bit in Microsoft, which has a 50% stake in OpenAI.
Oh, yeah.
I think they did a little similar, dippy back down and up.
Yeah.
Yeah, well, they would have invested a lot, but it's wild because, so much of their business has nothing to do with OpenAI, right? So it would have been, it would be fascinating to see exclusively a business like Anthropic or, being listed.
Yeah.
Now, I have a follow-up question, which is talking about kind of LLM size to performance and kind of that ratio. And we've talked about sizes of models a lot, how you have kind of the foundational bleeding edge, which is going to be obviously the largest with the most parameters, and then so on and so forth. And it goes all the way down till you get to edge computing like your phone. And I was kind of just wondering about, how does distillation fit into this? And that kind of relates back to open source as well. And the size of models. And I guess where do you see kind of the future of this use, and what ends up happening with, do models keep getting bigger, or do we start distilling them smaller and smaller and more efficient, or what do you think? The direction.
That's a big question. I think starting with distillation. So maybe for the viewers at home. So distillation is sort of the process of taking a big model that is, generally bigger models have better performance, and using that model as a teacher effectively to teach a smaller model and kind of upgrade its performance. So it's actually called a teacher. Some of the ways that do this involve a teacher-student framework, and that's the name, which I think is pretty intuitive. But effectively, you have this kind of like a reinforcement learning sort of framework where the teacher kind of says here's what my response is, and the student kind of goes, here's what my response is, and then you can sort of change the parameters of the smaller model to sort of update it and make it more closely aligned to the larger model. So the funny thing about this, and relating back to our earlier conversation about DeepSeek, is that that's exactly what OpenAI has kind of accused DeepSeek of and has gone to court over. So, a lot of chat GPT-isms are found in DeepSeek. Things like, as a large language model created by OpenAI, which is a bit of a, when it comes to smoking guns, you don't get much more smoking gunnier than that.
Yeah.
Yeah, you ask it and you get the system prompt.
Yeah, exactly.
Someone at OpenAI.
As Sam Altman's baby.
Yeah. Exactly.
So the accusation effectively is that DeepSeek has sort of used that teacher-student model of distillation themselves. But generally speaking, when you're talking about distillation, you're talking about kind of making something smaller, much like in chemical distillation. You're kind of making it more like refined or pure or whatever. So a lot of the time these big research organizations are training their enormous models, which cost lots of GPU time, lots of energy, lots of carbon. And they can then use that kind of model to create smaller versions, which are almost as performant, but not quite. So whenever you see like a family of models come out, that term, like a family, is basically you have this big model and it teaches a bunch of small models. So, for example, Quen had the Quen 3 series of models that came out, and Quen 32 billion, Quen 14, Quen 8, Quen 4, Quen point something, point 8 or something. And that was basically this like chain of models that was all taught by the big model, I assume. So, sorry, I forgot what the second half of your question was. It went on a tangent.
It was just about kind of where that travels after this, right? So, do we keep getting smaller and more distilled, or do we get really big models? Because especially if it takes away from some of the advantage of having a really big one when someone's just going to distill yours down to something else.
Totally. And I think since that technique became popular, there was less and less reason to run these huge models because you could get most of the performance at a fraction of the price from the smaller ones. So maybe to give an indication of that, you can have, say, for example, something in the realm of, there was this big foundation model that Meta put out called Llama 3, 3.2, 400 billion parameters, I believe was the size. And then we had Llama 7B, which was their like small sort of flagship. And the amount, if you wanted to generate 1 million tokens from each of those models, it would take you something like 30 seconds on the 7 billion parameter model. And then for the equivalent, on the equivalent hardware, it would take you like hours on the large one. And so I think I did some back napkin maths. I'm sure people who kind of are into the carbon accounting of this could probably have a much better guess. But I think for the million tokens is the equivalent of driving about 20 meters in your car, your petrol-powered sedan, for the small model to get those million tokens. That's how much carbon it used. For the larger model, it was about 2 kilometers. So if you think about kind of the carbon cost of that. So I'm hoping that, and what we do at my work is we run these small models, we fine-tune them so they have equivalent or better performance than the large ones. And in fact, we use that distillation technique to create the training data that teaches our models. And then we can run them much more efficiently. And I sleep a bit better at night knowing that we're not burning quite as much coal.
Yeah.
It seems like such a smarter, and I love how it is a more efficient way of doing it, because that's the thing, like you've got this great capability, but at what cost, and like how broad are you doing it? We talk about it all the time.
Totally.
The energy transition of completely overbuilding and completely overdoing stuff versus what is the most efficient way to do it. We're actually getting close to time, so we've got one sort of final question for you, and this is more, I guess, on the downstream applications, but where do you see the best value capture in the chain from foundational models versus tools or wrappers of AI?
Ooh. And just to clarify by value capture, what exactly?
Value in terms of like financial, like who's the winner in the company?
Gotcha.
Is it the wrapper on top, or is it the builder of the foundation?
Or is it the picks and shovels?
Oh, that is such a fascinating question.
yeah, true. Is it the...
So a year ago, you would have said like anyone can build a ChatGPT wrapper, like ChatGPT is the value there. But as we're talking about with this like commoditization of intelligence, suddenly there's lots of foundation models out there, and ChatGPT isn't looking quite as the king of the hill as it used to. So I don't think it's the foundation models. By the same token, like the ChatGPT wrappers of the world also aren't faring too well. I think a lot of people learned how to prompt, and these models are just going to get easier to use over time. Like half the reason that we have AI and it works so well is because it's a general purpose tool. So if you can't make your general purpose tool do your general purpose task, then what's the point of it, right? I think the thing that I'm seeing not going away at the moment is these like use case specific tools that harness language models in specific ways. And I'll admit I'm very biased because that's where I work.
Yeah.
But effectively, you've got humans who have domain expertise who are able to like adjust these systems and build them in a way that both harness the human expertise and also the kind of raw intelligence or raw computational ability of these language models. So I think we're able to fuse like human expertise with language models is going to be the hardest place to come unstuck. That said, this industry is just going to keep moving in random directions, and what you thought was safe yesterday won't be safe tomorrow. So it's hard to know.
It's so hard to tell. And it's so hard to know who has a moat and who doesn't.
Exactly.
Yeah.
I think your biased response in that is very fair and valid, though, because you've seen and you are, extracting some of the value out of the whole ecosystem. So, and obviously it's working and paying dividends. So that's really interesting. Last question, and this is a wrap of the whole thing. If a listener can only get one thing out of this discussion, what would be your key takeaway?
Ooh, I would say, and if I had to give like a recommendation to anyone listening, I would say go download a model and play around with it. Go see what's out there like on the internet that you can download. So go grab Llama or the new Quen models are awesome. Download a tool that allows you to run them on your computer. So something like Ollama, and just see how it works. There's nothing quite like playing around with stuff. I'm kind of a engineering buildery type myself. I know that's kind of what makes me happy, but I think you'd be really surprised like how much you can be self-sufficient and how much this is all fair game. The playing field is wide open. So yeah, give it a go.
100%. Yeah, that's awesome. Thanks so much for joining us, Mitch.
Yeah, pleasure to be here. Thanks for having me.
Thanks for listening. Find us at thecuriositycrisis.com and Curiosity Crisis on Instagram. We're on all major streaming services, so you can listen how you like. We'd like to just ask a quick favor. If you could share this with a friend, your recommendation means a lot. Thanks, and we'll catch you in the next episode.